Now mechanisms, part 1. Okay, now what is mechanism? It is actually an assembly of moving parts performing a complete functional motion, and often being part of a large machine, and sometimes is known as linkages. Okay, so basically when you refer to this chapter, we will be only using the graphical method or drawing method instead of using the cross product for the section. So those you will learn in your further studies. Now mechanism, that is an assembly of moving parts performing a complete functional motion, and often is being part of a large machine, or is known as linkages. Now for example, when you refer to this is a rod or a link. Okay, it can be made up of a steel rod or a steel bar. Okay, so this point A here is a fixed point, and point B is actually a moving point. So when the bar or when the rod here oscillates or rotate or oscillates about point A, what happens is at point B you will have a relative velocity of the point B itself relative to point A, which is fixed. Point A is fixed. Okay, so I have written here, okay, what we have here, tangential velocity of B. This point B here is moving actually, but point A is not in this case. Okay, it is fixed, okay, at this point A here. Okay, so tangential velocity of B moving relative to A, so that is denoted as VBA. So the first alphabet here, B, is the moving point. Okay, it is moving with relative or with respect to point A. Okay, so that is why you write it as VBA and not VAB. So if you write it as VAB, it will be velocity of A relative to B, but A, we know that it is not moving, so it is impossible. So that is why we wrote it as VBA, that is velocity of B relative to A. So, and this velocity VBA here is always being 90 degree. Okay, so if let's say for example we use vector, okay, diagrams, or that means when we use graphical method, okay, always at any of these members here, links or rods, okay, always we tend to draw a perpendicular line, that means a line which is perpendicular to the member, that is to the rod, that representing the velocity component of that particular point with respect to the other one. So this line that we have drawn here, the VBA, must always be perpendicular to the oscillating link or the bar. Okay, so remember point A is fixed. So omega is the rotational speed or the oscillating speed of the bar AB or the link AB. Okay, omega is in radians per second. So if it is given in RPM, revolutions per minute, remember you have to multiply by 2 pi divided by 60 in order to convert it to radians per second. If it is in revolutions per second, then you only need to multiply by 2 pi. So the rod AB is oscillating about the point A, which is fixed with a speed of omega. So what I can do here is we can set up drawing a vector diagram based on VBA. First thing is, if we were to draw a vector diagram, there are two things that we have to remember for vectors, okay, quantities. Okay, we must have first the magnitude, magnitude, that means the size of the velocity, how many meter per second, okay, or how many millimeter per second, or how many centimeter per second. Okay, that is the magnitude. Then the next one is the direction. So the direction is being defined here already. First thing, 90 degrees to the rod or the bar, and then it is pointing towards these directions, that means upwards, okay, that means towards the right hand side, okay. So when it is oscillating in the clockwise direction, when this thing here rotate in clockwise direction, so if it rotates in anti-clockwise direction, this arrow here should be pointing downwards because it is rotating downwards in towards this direction. So the arrow should be pointing the other way around. So that would be your VBA if this is rotating in an anti-clockwise direction. So once we know the magnitude and the direction, then we will be able to scale it, okay, by taking 1 cm is equivalent to how many meter per second. And then what we can do is we can just simply put a point, okay, at the side of your papers that represents the fixed point, and then draw a line which is parallel to this line here that I have, the blue line here. First, you have to put a point that represents the fixed point, that means in this case is A, and then from that point you need to draw a line parallel to this line here, parallel to this line, okay. So and then the length of this, okay, it is the magnitude of the velocity which you have scaled it to cm, okay. So velocity of any point on a link with respect to another point on the same link is always perpendicular to the line joining these points on the diagram shown, okay. So velocity of any point, that means velocity of point B, okay, with respect to the fixed point A, okay, what you have to do is you have to draw a perpendicular line that, okay, join both the points here. So this line here should be perpendicular to both the points here, okay. So this is what you have. So it oscillates about the point A, okay, it oscillates about its point A, okay. So therefore you have VBA here in this case, okay. At this position, this is your point B, so your VBA, if it is in this case, should be pointing in this direction, okay, at this instant. And this line here is perpendicular to this line that is joining both the points, okay. In this case, when the rod is at this angle, you can see the velocity component is in this direction. When the length goes up to this particular angle, then the component of velocity should be pointing downwards in this direction, okay. So now here I will give you an example of a three bar linkages, okay. Now find the tangential component of velocity using relative velocity method or graphical method. Now in this instant here, you have a piston cylinder mechanism. So from this you can see there are points like O, which is the fixed point, okay. The link OA is pivoted at point AO, okay, and then you have points OA. So what you can do is draw a line joining up O and A, and draw another line which is perpendicular to O and A, which represents the direction of the tangential velocity of point A relative to point O. So you see I have written here as VAO and not VOA, okay. So this is an example. Now then you have the next, that is the connecting rod from A to B, okay. So here again you have 2 points, draw a line, join point A to point B, and then draw another line which is perpendicular to the line that you have drawn from A to B, okay. And this perpendicular line should represent the velocity of A relative to B, or either B relative to A, up to you, okay. But the direction of the arrow will be different, okay. So this is A to B, so you are considering that the velocity of A, you are looking at velocity of A relative to B. Now, then the next part is the piston. Okay, the piston that is within this guide here. The guide here is to restrict the pistons to move in only the horizontal direction parallel to the guides. Sorry. So for piston or for this, okay, moving component here or the slider, the piston or the slider here, you should draw a line. You can see that blue line here. Okay, you should draw a line that is parallel to the direction of motion of the slider or of the piston. So I have drawn a horizontal line here across, which represents the velocity of the slider. Sorry, the velocity of the piston or the slider relative to the fixed point O. So please bear in mind when you refer to piston or any sliders, okay, the motion of the slider or the pistons always being taken relative to the nearest fixed point. So that is why I have written here as VBO. So that is velocity of B that is moving relative to point O, which is the fixed point. Okay. So now I will be explaining here step by step. Now, first step, draw the space diagram to scale. Now, this is the space diagram. So if it is given, the dimensions are given, then you will be able to draw it perfectly. Okay, with the angle here, with the length of this crank and the length of the connecting rod, the distance between the fixed point to the slider at that instant. So you will be able to draw this diagram, okay, according to the scale. You have to scale it, okay, you have to take 1 cm or 1 mm, usually we use 1 cm, is equivalent to how much of the OA length, AB length, and the distance of OA. And of course, you need to know the angle in this case. Now draw the space diagram to scale. This is the space diagram. Then the second step, draw perpendicular lines. Draw perpendicular lines. Now draw perpendicular lines that I have marked as red color here, on each member, rod or bar, and straight lines onto any sliders according to its guide or its these guides here. Okay, because it's restricted to move in this direction. So you can see the first red line that I have drawn perpendicular to OA. The next red line that I've drawn is perpendicular to AB. But for sliders or pistons, remember the line that you draw must be parallel to the direction of motion of the slider or the pistons with respect to the fixed point. So this, as you can see, OA is oscillating in the clockwise direction. So this arrow will be pointing downwards. And then you are taking A relative to B. Okay, so this arrow here will be pointing downwards because as you, let's say for example, imagine, okay, if OA is sliding towards this direction or oscillating towards this direction, what is going to happen to AB? Or you don't have to put the arrow first, you just draw the line first, because finally when you draw this diagram here, which we call velocity diagram, you will be able to determine the direction of VAB. Okay, now step 3, convert any angular speed to tangential speed, that is into meter per second. So let's say this omega here, the rotational speed here. So it is given in RPM. So first thing, you convert to radians per second. Then you take the radians per second, that means the angular speed which is in radians per second, multiplied by the radius of OA, which is in meter. then you will be able to find this VAO in meter per second. So remember, omega times radius OA, or omega times the length OA, times the length multiplied by the length OA, or times the length OA, you will get VAO, the velocity in meter per second. Okay, it will be shown in your example. So once you have converted it, this one, okay, into meter per second, so you have this VAO. So once you got this value here, okay, you can use scale by taking 1 cm is equivalent to how many meter per second here, okay, and then you get the magnitude of the line that you are going to draw. That means the value of the line that you're going to draw, the length of the line that you're going to draw. Okay, so first thing is you put a fixed point here. Any fixed point, okay, within the empty space of your paper. So just simply put a point, and the first point that you put must be referring to the point O. That means must be the O, anywhere you like. You want to draw this point here, over here also you can. If you want to draw it over here, you can do so. If you want to draw point O over here, you can do so. Okay, but then you must make sure that you have enough space for you to accommodate the other lines as well. So you put your point O, simply put your point O somewhere else. Okay, then from point O, this is the first value that you have got just now. Okay, which is in meter per second. Okay, which is in meter per second. So you convert it into cm. So from point O, you draw a line, this line here, parallel to this, 1, parallel to this 1 here. So the 1 is here. So this line should be parallel to this. And the direction, you have to see the direction here. So once you got this line, okay, so that is your point O. First you put a point O, then you draw this line. This line is parallel to this. The length of this should be equivalent to this, how many meter per second, but has been converted to cm. Then the next one, okay, you don't know. Okay, this and this here, you won't know. So what you have to do is, now 2, okay, 2, the slider, okay, with respect to the fixed point O. You can see the guides is here, so it is restricted to move only in the horizontal direction, okay, but this arrow you shouldn't be able to determine or able to know the direction yet. So what you need to do is, from the point O, what you can do is you just draw a straight line. Look at my laser pointer. You just need to draw a straight line across point O like that, without knowing the arrow, the direction of the arrow yet. Okay, you can just draw a straight line across point O like that. Follow? Then, okay, you have already drawn this VPO, which is unknown yet. So that is why you don't know the length. Okay, you only know the direction. Straight line across. Towards the right or towards the left also you don't know. So that means you don't know the arrow at first, actually. Okay, so you have this line across point O. Then the next one is your tree. That means the member or the link AB. So you got this line here, which is drawn perpendicularly to the line that you have joined A and B. The arrow you don't put first. You don't know the arrow, which direction yet. So you just refer to the line only. So from either end, because if let's say this is your horizontal line, if you were to draw this line here over here, it will not meet, and then it becomes infinity. Okay, it will never join. So if you were to project this line over to this point that you have just now, OA, that is the only length that you know. So you project this line over to OA, that means at the end here A. Okay, so you will have this line here intersecting with the straight line that you have drawn just now at this point. So once you got this point, then you know, okay, that this thing here is oscillating downwards, and this thing here is moving towards the right. So you have determined actually the VBO, the length is how much, and the AB length is how much. So by knowing the length of the line BO, okay, divided by or multiplied by the scale that you have fixed just now, you will be able to find out the velocity of BO. And knowing the length of the line AB multiplied by the scale, you will be able to know how much is VAB, and the direction down, this direction is towards the right. Okay, so that is what is all explained here from step 1 to step 8. Okay, so this is one of the example. Okay, in a 4-bar chain ABCD, AD is fixed and is 150 mm long. AD is fixed. That means both the point A and D, they are fixed. The length from A to D is 150 mm. So you can use a scale of 1 cm to let's say 25 mm. 25 mm. So if you fix it 25 mm, this would be 6 cm. Am I right? So 6 cm long from A to B. So you can draw, you can fix both the point A and D, sorry. This is your space diagram. First thing I remind you, you have to draw the phase diagram first. Then draw crank AB, which is 40 mm long. So you have taken 25 mm to 1 cm, or 1 cm to 25 mm. So it is 40 mm. So it is roughly 1 point something cm from A to B. Okay? Then you know the angle. Definitely you will be able to draw the line AB. So once you got the line AB, and then they have also given us CD is 80 mm in length. CD. So from C to D, use your compass, measure 80, but it's not 80, you have to scale it to 1 cm equivalent to 25 mm. Okay, then you draw the line, use your compass, draw an arc CD from the point D, draw an arc CD, and then BC, you should know BC, or from the point B, you draw a line connecting to the arc that you have. So you will be able to find the point C. Okay, you will be able to find the point C because you have already known this is 60 degrees. Okay, so at this point here, you draw a line across. Okay, so let me read the thing properly. CD is 80 mm. BC and AD are of equal lengths. BC, this BC here, and AD are of equal length. So AD just now they have given 150. So with the 150, that is the 6 cm, because you have to scale it, 6 cm, place your compass at point B, draw an arc here. Draw an arc here. Okay, and then at point D, 80 mm, so 25, so it is roughly 2 point something cm. Draw another arc across like this. So when both the arc intersect, you got point C. So this is your space diagram. So first thing you have to draw a space diagram. Once you have got your space diagram drawn, remember each of these member here, A, B, B, C, and C, D, you must draw perpendicular lines like that. Okay, perpendicular lines. Make sure is perfectly perpendicular or 90 degrees. Perfectly 90 degrees. So you have to use a protractor for this CD, BC, and AB. So you got this line, and this line. So and then they have said, okay, that this CD here or this AB, which is rotating at 120 RPM, is in clockwise direction. So I'll put here clockwise direction, 120 RPM. So 120 RPM converts to radians per second. So you have to times with 2 pi divided by 60. But that will be only in radians per second. How to convert it to meter per second? Meter per second. So AB is how many meter? AB is 40 mm. 40 mm is how many meter? 0.04 meter. So what you have got just now, omega in radians per second, multiplied by 0.04 meter, you will get the velocity of B relative to A in meter per second. So that is 0.503 meter per second. Okay, then from point B, draw a vector BC perpendicular to CB. I've drawn, and then this line also as well. Now, what you need to do now is, okay, your fixed point are both A and D. So the first point that you draw here, should be the first point. You can place it here. Your point A can place it here. Make sure you have enough space here. Okay, so point A, that is your point A, referring to this. Now I'm using lowercase letter for the vector diagram, and I'm using uppercase letter for the space diagram. So lowercase letter is A here. So this should be A comma D. A, you can put here A, the lowercase letter A, comma, lowercase letter D. Why? Because both A and D, they are fixed. So they are not moving. So that means they are at the same point, A, comma, D. So from A, you need to go to B. So I have got this velocity here just now. But remember, for velocity diagram, you have to use another scale of 1 cm equivalent to how many meter per second. Just now you have to use a scale for the space diagram. 1 cm is equal to how many mm. Now you have to use another scale, that is to draw the next diagram. 1 cm is equivalent to how many meter per second. So once you have got the scale, okay, you got the length of this VBA, how many cm, okay, then from point A, you draw the line that is parallel to what you have marked here. Draw it, okay. This line should be parallel to this. The length is how much? It depends on how many meter per second you have here and converted to cm. So this is the first line that you have drawn, and you know the direction, the arrow, because it is oscillating in clockwise direction. So it should be pointing towards this direction. So once you got AB, now what is the next thing is this here. This is referring to BC. BC. So from here, you have already got B, right? So you need to draw a line on point B here. Draw a line on point B. You don't know the arrow yet. The direction you don't know yet. Okay, you need to draw a line on point B, which is parallel to this component here. Parallel. Okay, you draw cross point B. Okay, across point B until below point B in this case. Okay, so then once you have got this line drawn, okay, from top to bottom, okay, then from point A again, or D, because D here, okay, DC. So that is why I say put A comma D. So A or D, that is this, DC. So from point A or point D, you draw a line parallel to this component here. So this line here. So when both this line intersect, you will get your C here, the lowercase letter c, not the uppercase letter c. So you must be able to differentiate what is space diagram and what is velocity diagram. So this is your point C. So from after putting a point C, then you know that okay, because this is point A is fixed, so this is your moving point C. So that means it is always the arrow always pointing from fixed to moving. The arrow is always pointing from fixed to moving. So this is fixed, this is moving. So there should be an arrow like this pointing from A to C. So you will get V, okay, VCD or VCA. You can write it as VCD or VCA. Usually we write VCD because there's relation between C and D. So that is your velocity C relative to D for this line here, or CA or CD. Okay, so BC, that is this. Now you know that, okay, once you have drawn, okay, that the arrow should be pointing downwards now. Okay, so you just put it downwards and then you put B relative to C because your arrow is pointing towards B. You can put your arrow pointing towards C also, up to you. Okay, because both points are moving points. Both points are moving points. So there is no fix whether it is BC or CB because both are moving points. But if you put BC, that means you say B is moving relative to C. Okay, so once you got this diagram drawn, that means you have found out the velocity of CA and the velocity of BC. Okay, And then if let's say for example you want to find the angular speed of this and the angular speed of this, then you need to take the velocity of this component and the velocity of this component divided by its length here. If you want to find omega BC, you must take VBC divided by BC. How much is BC? BC is 150 mm, so make sure it's divided by 0.15, not 150. And then you have your CD. Your CD is 80 mm, so you must take your CA or CD, how much in meter per second here, divided by this length here, which is 0.08. Then you get your omega CD and your omega BC. Okay, so in this case for CD is 4.8 radians per second. Okay, by graphical method you will not get, okay, the exact value of this. Okay, so you take an approximate of plus minus 5% of the answer. So when I mark or when I correct your papers, that also will be based on plus minus 5% of this value. Okay, because you are using graphical method. Okay, that's all for this section. Then we will continue with part 2, okay, in the next lesson. Thank you.